everyone, I'm Wan Li. I have been explaining regression analysis from the simple linear regression model. This model has only one explanatory variable, right? We have to understand least squares estimation method and how to estimate error variance, and you better understand statistical properties of beta 1 hat and y hat as well. And we have ANOVA table in regression analysis. And important concept in regression analysis is determination coefficient. So what is determination coefficient? And residual analysis, what is that? There is an assumption in the model about error, epsilon. So we have to check whether or not that assumption is correct. The assumption holds in your data. That's why we need residual analysis. Now, we come to the multiple linear regression model. What is that? When you have two or three more explanatory variable, then we call that multiple linear regression model. Okay, let's see. The simple linear regression model involves one explanatory variable, while when they are two or more explanatory variables, it is referred to as multiple regression, linear regression model. In regression analysis, having only one explanatory variable is often insufficient. One explanatory explain the response. Why? It is not frequent. That is, multiple linear regression model with p many explanatory variables is given by yi equal to beta 0 plus beta 1 xi1 plus dot 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 plus beta p xip plus epsilon I from 1 to n. Assumption about error, epsilon. Epsilon follows normal distribution with a mean 0, constant for all I, constant what? Variance. That is assumption. The data obtained from samples for this model can be organized as follows, like this. Y, for variable y, response variable y, data y1, y2, yn. Okay, this is a sample number 1, 2 up to n. x1, x11, x21. The first subscript denotes the number of a sample 1, x21, 21, xn1. Okay, x2 for variable x2, x12, x22, xn2. Two subscript, and you have to note the order of subscript. So sometimes if you understand vector and matrix, y vector equal to it is some complicated thing, x11, x21 up to xn1, and x1p, x2p, xnp times beta 0, beta 1, beta p plus epsilon. Okay, epsilon is error. This is a multiple linear regression model in vector and matrix. Okay, if you don't understand this kind of vector and the matrix, that's okay in this lecture. So I will not explain this part again. Okay, so don't worry about that. Anyway, somebody who has strong background of mathematics, then they will understand that what I'm talking about. Similar to simple linear regression analysis with only one explanatory variable, the coefficient beta 0, beta 0, beta 0, beta 1, beta p should be estimated using least square method. Okay, you cannot solve that many equations, so they use vector and the matrix. Anyway, the estimated regression equation the result will be y hat equal to beta 0 hat plus beta 1 hat x1 plus dot 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 plus beta p xp. Okay? And what is the residual? What is residual? Always ei equal to obtained value minus estimated value, the value of y hat. Okay? So there are n many residuals in this case also. In three dimensions means y and x1, x2. x1 only two explanatory variables case. This will define a plane, not a line now. Plane determined by the values of beta 0 hat. Beta 0 hat is an intercept. Beta 1 hat is coefficient of x1 and beta 2 hat is a coefficient of x2. Okay, the value of these three values determine a plane like this. The blue dot point is value position, and this one, this plane is estimated equation, and what the residual is the value from the point you value observed value to the value on this plane. Get it? The residual is parallel to y-axis. This one is y. Here, x1, here, x2. Okay? x1, x2, y. Then residual is from the obtained sample value to the value on the plane. Understand that? Okay, this is a introduction of a multiple linear regression model. So it looks some complicated, right? So there are some many topics, many analysis, what types? I mean analysis method, analysis topics. Okay, analysis topics in multiple linear regression model, of course. Okay, that's it today. Thank you. Bye.